Number 11. So when they do questions like this, it's the main criticism. There may be some other problems, but which is the biggest problem? No control group. Remember, we have to have something that we can compare our results to, otherwise we can't really say anything. So E is a problem. Let's go to number 12. This is confidence level, not confidence interval. So the confidence level is saying if we did this process over and over and over and over again with the same size sample, 90% of our intervals that we would create would capture the true mean. The one of these that says that the closest is letter D. It's our success rate when we do it over and over and over again. So yeah, 90%. If we did 50 times, we would expect that 90%, 45 of them, would contain the true mean. Okay, that's letter D. Number 13. So number 13, we are testing to see are the proportions of Asian carp in these two water sources the same, the same, or are they different? Now, there's a very low p-value, which means we're going to reject the null hypothesis. See, we're going to reject this and say, yes, they are different. Which one says that in the best way? E. The p-value of this test is smaller than most reasonable significance levels, indicating sufficient evidence to conclude their difference does exist. E is the answer. Let's go to 14. Number 14 is simply saying what are we doing this experiment to? It is the individuals or the units are the 140 plants. Letter A. Number 15. Now remember, let's see. The area under this is 1, this curve. So the area under this curve is 1. So if we go out 4 like this, one of the keys is how high is that? Well, this number right there has got to be 0.25 because 4 times 0.25 gives me 1, the area under the graph here. Now let's talk about less than 0.7. So I'm just going to draw a line where I think like 0.7 is. So it's kind of like this, and we're looking for this area right here, and it's 0.7. So how will we find that area? Well, it's the area of a rectangle. So we would say 0.7 times 0.25. That's the area of that graph, which is letter E. So number 16, there's quite a bit of stuff there that you can mix up, but remember, let's see, remember, what do we expect the difference to be? Well, the difference between 32 and 23 is 9. That's what we expect. But what if we take a look at, we're looking, the thing that we're interested in, right? What we expect versus what we're interested in is 5. And then the new standard deviation. So what we do is we square them, add them, and take the square root. So it's, what is it, 4 squared plus, what is it, where is it, 6 squared, and take the square root of that. That's your new standard deviation. What do you do with that number? Well, you would do normal CDF. Normal CDF. Okay. And it's less than, right? So we're not going to subtract it from 1. And when we do that, we get 0.29. So number 17, they don't even tell you what the two variables you're comparing, but if you remember, a least squared regression line looks like this. You've got the x and the y, whatever they are, and I mean sometimes, like, let's say it's time and money, something like that. How much do you make? And we look at these different people like this. So least square regression line is how well does this data fit? Can we draw a line right through the middle like that? Now, this 0.68 tells you how well it fits. So remember, we need to be like at 0.85 or higher for it to be a good fit. So this is not a very good fit, but that doesn't have anything to do with this question. What we're going to do is, what if we flip-flopped those variables? Well, you would still draw a line through the dots, and the dots would still be kind of the same distance apart. In other words, let me see, if I flip-flop these, it would just go like down, I guess, right? Like this, if you flip-flop them. But the dots are still the same amount apart, so it's going to remain the same. Number 18 can be a little bit confusing, because I was thinking, are we talking about the phone plan or the juniors and seniors? But right down here, it restates juniors versus seniors right here. So letter A would be the best one. The proportion of juniors and seniors feel the smartphones are a valuable learning tool is the same, right? Versus they are different. Okay. Letter A is the answer. Okay, so on this one, remember, the population can be wacky. So we can start out with the wackiest one, which to me looks like this. And as the sample size increases, you're going to get a more normal distribution, kind of approaching that central limit theorem, something like that. So with a sample size of 2, we're getting a little bit better. Sample size of 10, we get a little bit closer. This one's a little bit skewed on one side. And then 25 goes right to a pretty normal distribution. So letter B is our answer. So on number 20, what is the probability that a randomly chosen person from this group is a researcher given that the person has a doctorate? Okay, so we're working with this group, given they have a doctorate. So there's 111 people that have doctorates. What's the probability from this group, right, given that they have a doctorate, that they are a researcher? So it's 41 out of 111. Divide those two numbers and you get letter D. Let's look at number 21. So number 21, there's a lot of stuff here. Well, let's take a look. We're looking at unpleasant side effects, right? So this is for Adaflu. 45% have unpleasant side effects. Suppose 70 people take Adaflu. Okay, so we would say 45%, 0.45 of the 70 people for Adaflu. So let's do the same kind of process for the other one. Let's see. Beneflu, 55, unpleasant side effects for 25% of the people, and 90 people tried that. So we're going to do, what is it, 0.25 times 90, and we'll just add those two together, and you should come up with 54.